Next we are going to solve some workbook questions. Now the question is question number 41. A message MT band limited to the frequency FM has a power of PM. The power of the output signal is given in figure. You can see that MT cos omega naught t is the input to the multiplier and it is multiplying with cos omega naught t plus theta. So actually it is followed by the low pass filter. So we can see that this is nothing but the synchronous detector with some phase error, and synchronous detector with some phase error we have already studied in case of demodulation of DSB-SC. So in question number 41 we have the figure like this. The input is MT cos omega naught t, another input is cos omega naught t plus theta, followed by low pass filter with unity gain and cutoff frequency FM. Cutoff frequency is FM and gain is 1. So we have to calculate the power of output. So output of this multiplier is x1t or simply xt, and output of this low pass filter is yt. So value of xt would be multiplication of these two, which is mt cos omega naught t into cos omega naught t plus theta, multiplication of these two, and we can apply cos A cos B formula. So 2 cos A cos B, so this is mt by 2, 2 cos A cos B is cos A plus B, which is cos 2 omega naught t plus theta, and cos A minus B means cos of theta. So low pass filter is having cutoff frequency FM, so this mt by 2 multiplied with this 2 omega naught, so the spectrum will shift to 2 omega naught, so it will not pass through the low pass filter and it will pass through the low pass filter because this is a constant term, and multiplication with mt by 2 only affects its amplitude, and the output y of t is mt by 2 cos theta, and when we calculate the power of yt is integration from minus infinite to infinite, 1 upon t integration from minus t by 2 to t by 2 m of t by 2 cos of theta magnitude square into dt, and here we get cos square theta by 4 as a constant, and we will get 1 upon t integration from minus t by 2 to t by 2 m of t magnitude square into dt. So here cos square theta is a constant term, so it is independent of time, and by 4 these are all are independent of time, and this will give me a power of message signal, because this is nothing but 1 upon t integration over the time period message signal square and dt. So it is nothing but the power of message signal, and it is given that the power of message signal is Pm. So we will get Pm cos square theta by 4. So this is the answer. Power of output of low pass filter is Pm cos square theta by 4, which is our option D. So the correct answer for this question is option D. Next is question number 42. Consider the signal s of t equal to mt cos 2 pi fct plus m cap t sin 2 pi fct, where m cap t denotes the Hilbert transform of mt and the bandwidth of mt is very small compared to fc. The signal s of t is. So it is given that s of t is equal to mt cos 2 pi fct plus m cap t sin 2 pi fct. So which kind of signal is this? It is asked. If you consider MT, if you consider the MT spectrum of MT, then if we multiply with cos, then it will shift to the cosine, some frequency Fc, and m cap t also shift to the some frequency Fc. We also know that whenever we modulate the signal become a band pass signal. Why? Because the message signal is a low frequency signal, and when we multiply it with the cosine signal or any high frequency signal, it gets modulated and the signal is converted into high frequency, or you can say the low pass signal is converted into band pass signal. So this is the expression of a single sideband suppressed carrier signal, because it is from the phase shift method. You can see mt cos omega ct plus m cap t sin omega ct. It means this is generated with the help of phase shift method, and phase shift method is used for generating SSB-SC signal, and SSB-SC signal means single sideband modulated signal, and if it is modulated signal, then the signal will be band pass. So because this SSB-SC signal is a modulated signal, it is a band pass signal. You can also consider mt as a cos or sine, and then you can find the range, and you know that if there is a plus sign and if mt is cos 2 pi fmt, then this s of t will become cos 2 pi fmt into cos 2 pi fct plus sin 2 pi fmt sin 2 pi fct. So this is low frequency signal Fc minus Fm. So it is a band pass signal because it is ranging from Fc to Fc minus Fm. Whether where we will get here impulse signal, because this is a cosine signal, but it is a ranging from Fc to Fc minus Fm for any other signal, and it is shifted to some high frequency because it is centered in the some frequency which is other than 0. That's why we will call it as band pass signal. So any modulated signal, you just remember this, any modulated signal is known as band pass signal because it shifts to the some other frequency called carrier frequency. Next is question number 43. In the following scheme, if the spectrum m of f of mt is as shown, then the spectrum of y of f will be. The spectrum of mt is given. Now in this block diagram you can observe that this is the multiplier. Multiplier can be considered as balanced modulator. This is a balanced modulator, this is also a balanced modulator. So in this balanced modulator, this message signal and the cosine signal is applied, where this cosine signal is having frequency B, and it is also B and minus B. And in the second balanced modulator, the input is after the Hilbert transform of message signal, and we have studied only the case in phase shift method where the message signal is applied to balance modulator after Hilbert transform. So here also the message signal is applied after Hilbert transform. It means it is somewhat related to phase shift method, because Hilbert transform we have used only in two cases till now. First is phase shift method and second is reverse method. So if the message signal is taking Hilbert transform, then we can think of those two methods. So message signal is after Hilbert transform is applied to the balance modulator, and this balance modulator is having other input which is sine 2 pi bt, which is Hilbert transform of this. So it means that the message signal and the carrier signal both are after Hilbert transform applied to balance modulator. That means it is nothing but a phase shift method, and the output of these two balance modulator are added together to generate y of t, which will be SSB signal, because this is nothing but phase shift method. So in phase shift method, when we directly add the two signals, we get the lower sideband. So what will be the lower sideband? So this is our message signal. When it is multiplied with this cosine signal, we will get double sideband. So what will be that double sideband signal? And this double sideband signal will be, first of all, we will multiply it by cos. So mt cos 2 pi bt, and we know that when we multiply it by cos, then it shifts to the cosine frequency. So 0 will be shifted to b. So 0 we have peak value. So now we will have peak value at b. This will be the peak value at b, and this will be 2b, and this is 0, and here we will be having mirror image of it, minus b and minus 2b. So this is a double sideband signal. Now we have to find only the lower sideband, because we are adding the signal of these two balance modulator. Output of this balance modulator are added together. Whenever we add, we get the lower sideband. Here we are having this as lower sideband, and this is upper sideband. This is lower sideband, and this is upper sideband. So actually at the output, this y of t is a SSB-SC signal, and it is lower sideband, because here it is plus only. So according to the option, the correct answer is option A. So you can directly solve the question if you know the block diagram of any particular method. The block diagram can be given directly in the question, but once you know the method name, you can tell the output of that block diagram. So here as I identified it as phase shift method, so I can conclude that this will generate SSB-SC signal, and if it is added together, then we will get the lower sideband. And what will be the lower sideband? So after modulation, we will get two sidebands, and out of which the lower sideband is selected and upper sideband is rejected. If the output of these two balance modulator is subtracted together, then we could have selected upper sideband. Now this type of question, if you cannot identify that this is a phase shift method, so this question can also be solved by the general method, which is bit lengthy, but you can solve it. So we have generated this double sideband, which is nothing but the output here of the first balance modulator. Let us say this is x1t. So we have plotted the Fourier transform of x1t. This is x1f. Now if we take the Hilbert transform of message signal, we have the spectrum of message, and how can we calculate the Hilbert transform? So Hilbert transform can be calculated by multiplying the signal with plus j and minus j. So this is the spectrum of message signal, and if we want to take the Hilbert transform of this message signal, we have to multiply the positive frequency by minus j and negative frequency by plus j. This is the concept. when we multiply it by h of f, which is minus j signum f. When we multiply these two signals, we will get Hilbert transform in frequency domain, because we are dealing in frequency domain. So when we multiply this, this is minus b and plus b. So positive frequency, which is varying, or negative slope, is multiplied by minus j, then the slope will become positive, because the slope was previously negative, then it will become positive now. And we will get the Hilbert transform of the message signal. Hilbert transform of message signal, m cap t, Fourier transform of m cap t. This is b, this is minus b, this is j and minus j. This slope is multiplied with negative value, and this is negative slope, now it is positive slope. So the slope is like this, it is positive, it is going down, down, and now it is also positive. So both the slope are positive. Now it is multiplied with, here in the second balanced modulator, it is multiplied with sin 2 pi bt. Whenever we multiply signal with sin 2 pi f naught t, what will be the Fourier transform of this kind of signal? The Fourier transform will be 1 upon 2j and x of f minus f naught minus x of f plus f naught. It means the signal is shifted to the frequency of sine and the amplitude is divided by 2j. So when we shift it to b, because the sinusoidal signal is having frequency b, so this 0, it will shift to b. So 0 will be shifted to b, so this transition will be at now b, and this will be 0, and this will be 2b. This is f, and it is multiplied with, this j is multiplied with 1 upon 2j, and we will get 1 by 2. This is x2f. x2f means Fourier transform of this output of second balanced modulator. And according to this property, the other will be shifted to the minus f naught, means the negative side, but the amplitude is also inverted. So this spectrum shifts to the b, and this spectrum will shift to the minus b, but that will be inverted. So actually it should be like this. If there is no negative sign, the spectrum should become like this, but because this is a sine wave, it is having inverting amplitude, and inverting amplitude, because of this inverting amplitude, we will be having the component in the negative side, which will be drawn here. And this is minus b and minus 2b, and this will be having minus 1 by 2, because this is j, the amplitude was minus j multiplied with 1 upon 2j, you will get minus 1 by 2. So this is the Fourier transform of x2t, which is the output of second balanced modulator. Output of first balanced modulator is this, and the amplitude is 1. So because of cosine wave, the amplitude is now 1 by 2 here. Now this is also ranging from 0 to 2b and 0 to minus 2b. This is also ranging from 0 to 2b and 0 to minus 2b, and these two are added together. So the slope is like, from here the signal is starting, so this is negative, negative, and here is the transition, and this is negative, negative, positive, positive, transition, and positive. And here the signal is positive, negative, positive, negative. When we add these two, because here the summer is used, so if we add these two spectrum, from 0 to b it is having positive slope, and from 0 to b it is also having the positive slope, and the slope is same because the height is 1 by 2 and the width is b, and here also height is 1 by 2 and the width is b. So these two will be added together, and now b and 2b, this is having positive slope, and from b to 2b this is having negative slope, and both slope are same, that's why they will cancel each other. It means there will be no spectrum between b to 2b, and the result will be only between 0 to b. Similarly, in the negative side, 0 to minus b it is negative slope, and 0 to minus b it is negative slope, and both the slope are same, that's why they will add and we will get the spectrum. And from minus 2b to minus b this is negative slope, and minus 2b to b this is positive slope, and they will cancel each other, and we will get the spectrum between minus b to b only, which was lower side band, as we have calculated here also. So that's why the correct answer for this question will be option A. So next is question number 44. The input for sink 2t is fed to a Hilbert transform to obtain yt as shown in figure below. Here sink x is sin pi x upon pi x. The value accurate to 2 decimal places of integration from minus infinite to infinite mod of y of t square dt. Here it is given that there is a Hilbert transform. This is a block of Hilbert transform. We are getting yt, which is Hilbert transform of input, and input is 4 sink 2t. Let us say x of t. So here we have to calculate integration from minus infinite to infinite y of t magnitude square dt. So what is this expression? This is the expression of energy of yt, because you know that if we calculate energy, we have already applied it in the Hilbert transform. So energy of any signal is given by integration from minus infinite to infinite, and the magnitude of that signal square into dt. So after looking this particular expression, I can say that this is nothing but the energy of output, which is the Hilbert transform of xt. This yt is nothing but Hilbert transform of xt. So from the property of Hilbert transform, we also know that the energy does not change. Energy of input and energy of output of Hilbert transform will remain same, because when we take the Hilbert transform, we only changes the frequency phase. So when the phase changes, it does not affect on the amplitude, and when the amplitude does not change, the energy will also remain same, because here we only take the magnitude, and when we are taking the magnitude, so phase will not affect its energy. So energy of input will be energy of output. So let's calculate the energy of input. Energy of input is integration from minus infinite to infinite x of t magnitude square dt, or minus infinite to infinite x of f magnitude square df from Parseval's theorem. You can calculate energy from this expression. If you know the signal, you can apply directly the energy of sink function, you can directly find, and if you don't know, then you can also calculate it from its Fourier transform. Suppose I don't know how to calculate the energy of sink function, that's why I am applying this particular formula to calculate energy. So for this, I have to calculate the Fourier transform of the signal, and the Fourier transform can be calculated by the result. We know a rectangular T upon capital T is having Fourier transform AT sink of ft, but because this sink is in time domain, so this is AT sink of t into capital T is having Fourier transform A rect f upon t. Now on comparing, we have signal for sinc 2t. So on comparing these two, we will get the value of A and t. So here on comparing, the coefficient of t is 2, here coefficient of t is capital T, so the value of capital T is 2 and AT equal to 4. So A equal to 2. Hence we get the value of A and t. So the Fourier transform of 4 sinc 2t is A, which is 2, rectangular, f upon t, which is also 2. So this is your x of t and this is x of f. So how can we calculate the energy of this? So we can draw the rectangular function. This rectangular function will be having width 2. Width 2, that means it is ranging from -1 to 1 and height is 2. This is x of f. Now energy we can easily calculate by this formula. This is minus infinite to infinite x of f magnitude square df. So we can calculate its energy of input, -1 to 1 magnitude of this, that is 2 square into df, which is, after calculating, the value is 8. So energy of input signal is 8. So because this is a Hilbert transform, so property, from the property of Hilbert transform, energy of output, that means energy of yt will also remain same, that is the 8. So the correct answer for this question is 8.